Hello, good day everyone. So we will look at chapter 1 for this course, that is circuit theory 2. So first we go through the chapter of two-pot circuits. So two-pot circuits, from the two-pot circuits chapter 1, you need to, at the end of the chapter discussion, you should have the ability to explain and analyze special types of circuits such as two-pot networks. So there will be like a 4 types of two-port networks will be studied. One is actually Z parameter, Y parameter, H parameter, and then ABCD parameter. So two-port means you have like a input and output, two terminal. Okay. Example of two-port is amplifier, filter. This is all actually two-port network where you have the input and output. And as for the one port, for example, let's say you have like an antenna, you have only one port. Okay, after that the antenna will radiate, so that's actually one port circuit. And for the as for the two port, we have, like as I told you before, you have like a 4 types of network that will be studied in this course. Okay, so you will have like a one input port, one output port, input and output. Okay, and then all these parameters that will be studied can be described from this equation. V1 equals to Z11 I1 plus Z12 I2, V2 equals to Z21 I1 plus Z22 I2, and similarly for other parameters it can be described as shown here. Okay, and we will cover 2 parameters today, Z parameter and Y parameter. Z parameter means it's actually impedance parameter. The impedance of the characteristic impedance from the two-port will be calculated or will be found, okay, according to this description. So this is actually mainly related with the equation will be given. All these equation actually will be given in the final exam. So you need to memorize anything. You just need to know how to calculate using this equation. Okay. So for example, let's say here you see they make all the I actually 0, I2 and I2 0 here to find the Z11 and Z21, and I1 0, I1 0 to find the Z12 and Z22. Okay, and if you refer to the equations here, let's say I want to find the Z11 and Z21. I need to make the I2 0, then only this actually will be cancelled, both actually will be cancelled. I2 and I2 here will be 0, means V1 equals to Z11 I1 will be remaining, and V1 over I1 equals to Z11. You see, V1 over I1 equals to Z11. Similarly, when I2 equals to 0 in the second equation as well, only these two things actually will be remaining. V2 equals to Z21 I1, Z21 equals to V2 over I1. You see here you will have V2 over I1 equals Z21. Similarly, when you make it I1 equals to 0, you see we won't have these two. For the first one, V1 over I2 equals to Z12, V1 equals to I2 equals to Z12, okay, and V2 over I2 equals to Z22, V2 over I2 equals to Z22. This is actually how it could be obtained just by looking at the equation and cancelling the unwanted source. Okay, and I2 0 means actually what in terms of circuit. This is actually in terms of the equation. We know that, okay, I need to make I1 0 to find the Z12 Z22. I need to make the I2 0 to find the Z1 and Z21. But I2 0 means what in terms of circuit. You see, and they say actually port 2 open, port 1 open, port 2 open, port 1 is open. So this means that when you want to calculate the Z parameters, you will open circuit. For example, let's say you want to find Z11 and Z21, you will open the port on port 2. Okay, port 2 will be opened. Okay, so when you open this one, you see, when a circuit actually open, you won't have a current flow. Okay, you can measure from the multimeter if you want. It won't have a current flow because no any complete circuit here, so obviously the I2 will be 0. Okay, and when things like this happen, okay, then only you can actually can calculate the V1 over Z11 equals to V1 over I1 equals to Z11. The parameter can be calculated. So I2 0 means I have to open circuit. When you want to calculate Z1 and Z21, you have to open circuit on port 2. And when you similarly, when you want to calculate Z12 and Z22, you have to open circuit at port 1. Okay, then this is like some extra notes where when Z11 and Z22 equal, you have get the equal value. Two port is said to be symmetrical, and when Z12 and Z21 it's equals, then the two port is actually said to be reciprocal. This is just like some notes from the characteristic of Z11 Z parameters. And this is one example where the circuit given as shown here, and you need to calculate the Z parameters. I will discuss this one separately in the discussion. Today we will go through the slides first, and these are the other examples where you can do later. Okay, and check with me. And admittance parameter, Y parameter, you know the admittance means it's actually 1 over Z, 1 over impedance actually admittance. So this is also another parameter can be studied. Okay, here the equation actually given as like this: I1 equals to Y11 V1 plus Y12 V2, I2 equals to Y21 V1 plus Y22 V2. Okay, and similarly like before this, we want to cancel one of the source and we want to find the parameter like this. So for example, let's say I want to find Y11 and Y21 means I need to off this source or make it 0. So this V2 and V2 0 means I will have the I1 over V1 equals to Y11, I2 over V1 equals to Y21. Okay, and similarly if I want to find the Y12, Y22, I need to cancel this, so I need to make a V1 equals to 0. If I make V1 equals to 0, I will have I1 over V2 which is equals to Y12, I2 over V2 which is equals to Y22. Okay, similar concept, but making V2 0 means what? That should be seen. So this is what similarly what actually I explained just now. So V2 0 means we need to short circuit the port. Why short circuit? Will make the V2 0. Short circuit means you don't have any voltage drop here, no load. So let's say you measure with a multimeter, you will get a voltage drop of 0. Okay, that's actually the basic concept. So when you make V2 equals to 0, you will get this equation as I discussed with you in the previous slide, and Y21 equals to I2 over V1, and when you make the what is that, this part actually short circuit, you'll have like a I1 over V2 Y12. Okay, and I2 equals to over V2 is actually Y22, and we will keep a current source here. Okay, previously for Z parameter we will keep a voltage source there at the port. Okay, and the port which is cancelled, we make it like a short circuit. Okay, and this example also we will discuss in the discussion session, and there are other examples as well. This also will be discussed in the, because this is really I cannot ask you to do by yourself because you have like a dependent source here. We'll be discussed in the discussion session as well. So thank you. Hope you can learn something from this session, and we will discuss the question in the discussion session.